What would happen if you fell into a black hole? This question has fascinated scientists and dreamers for decades. Let's embark on a journey to the edge of space and time to find out. Imagine you're an astronaut floating peacefully in the cosmos. In the distance, you see it a region of perfect blackness, a circle of pure void against the backdrop of stars. The black hole's immense gravity begins to pull on you. Now, here's where things get interesting. The force of gravity isn't uniform. The part of your body closer to the black hole gets pulled much more strongly than the part that's farther away. Let's say you're falling feet first. Your feet will be pulled with more force than your head. This difference in gravitational pull is called a tidal force. This tidal force would stretch you out, like a piece of spaghetti. Scientists have a wonderfully graphic name for this process: spaghettification. You'd be elongated, getting longer and thinner, pulled apart atom by atom. For a smaller, stellar mass black hole, this spaghettification would happen before you even reach the event horizon, the point of no return. You'd be shredded into a stream of fundamental particles before you ever cross the boundary. It would be a rather unpleasant and very quick end to your journey. But what if you chose a supermassive black hole? These cosmic giants, millions or even billions of times the mass of our sun, are found at the centers of galaxies, including our own Milky Way. Their gravitational pull is immense, but the tidal forces at their event horizons are surprisingly gentler. Why? Because the black hole is so large. The difference in gravity between your head and your feet is much less dramatic as you approach. So for a supermassive black hole, you could potentially cross the event horizon completely intact. You wouldn't feel yourself being torn apart. In fact, you might not feel anything at all as you pass this invisible boundary. From your perspective, as you cross the event horizon, nothing seems to immediately change. You're still falling, but for an outside observer, say, your friend watching from a safe distance in a spaceship, the story is completely different. As you approach the event horizon, they would see your image slow down. The intense gravity warps spacetime, causing time itself to tick slower for you relative to them. They watch you get dimmer and redder, a phenomenon called gravitational redshift. Your final moments before crossing the horizon would seem to stretch out for them, lasting for an eternity. They would never actually see you cross. They would just see you frozen in time, fading away at the edge of the black hole. But you, the intrepid explorer, have crossed over. You are now inside the black hole. What do you see? This is where our current understanding of physics breaks down, and we enter the realm of pure theory. Once you're inside the event horizon, there is no escape. The pull of gravity is so strong that not even light can get out. Every possible path you could take, every direction you could move, leads to one place, the singularity at the center. Looking back, you wouldn't see the universe you left behind. Because of the way spacetime is warped, the light from the outside universe would be compressed into a tiny, brilliant point. Looking forward toward the singularity is pure darkness. The singularity itself is a point of infinite density and zero volume, where the laws of physics as we know them cease to exist. All the matter that has ever fallen into the black hole is crushed into this single, incomprehensible point. As you fall toward this singularity, the tidal forces that were gentle at the event horizon of a supermassive black hole would now become infinitely strong. The spaghettification process would kick in with a vengeance, and you would be stretched and compressed until you were just a stream of subatomic particles, ultimately becoming one with the singularity itself. Falling into a supermassive one lets you cross the event horizon intact, only to be spaghettified later as you plummet towards the infinitely dense singularity. They challenge our understanding of reality and push the boundaries of science. While we may never be able to send a person on this one-way trip, thinking about it helps us explore the incredible forces that shape our cosmos. If you're fascinated by the mysteries of space, be sure to hit that like button and subscribe for more deep dives into the universe. Let me know in the comments what other cosmic questions you'd like us to explore next. See you in the next video.